In this video, we'll get another example of integration by u-substitution. Our problem is to evaluate the integral of 4x divided by the square root of x squared plus 1 dx. Now our first step is to choose an expression for u. So I'm going to let u equal x squared plus 1. Then when we do a derivative on this, we get du is equal to 2x dx. Now there's a number of different ways we can tackle this from this point. I can see that I have an x dx in my original problem, so I need something to sub in for x dx. I could also just solve for dx. So let's do that. Let's divide both sides by 2x and get dx is equal to du over 2x. Then when we sub in for our problem, we have the integral of 4x, and on the bottom we have the square root of u. And then in place of dx, we need to put in du over 2x. And like I said, that's just one way to tackle this problem. You can see that our x's are going to cancel out, and then this 2 cancels one of the 2 factors here in that term. So that gives me, I'll pull this 2 out in front, so 2 times the integral of u to the negative 1/2. That's just the square root of u written with an exponent, and then du. Now when I integrate, when I increase the exponent by 1, I get 1/2, and then divide by that new exponent. So dividing by 1/2 is the same as multiplying by 2. So 2 times 2u to the 1/2 plus a constant. So then if we sub back in, we get 4 times x squared plus 1 to the 1/2 plus c. Now let's just take a moment to do this if I go from this point. I would have my integral, and I have 2x dx that I can substitute for. So I can just make this 2 times 2x here. So I'll have 2 times, and then the 2x dx, I'll put in a du for that. And then I'm dividing by square root of u here. So again, this simplifies to 2 on the outside, and then u to the negative 1/2 du, which is exactly what I had at this point. So it's whatever you see to sub in for.